Hey there, Mr. Weaver here, and this is the Geometry Unit, Lesson 2, Angle Relationships and Triangles. After this lesson, you need to be able to find the measures of interior and exterior angles in a triangle using the relationships between these angles. Let's learn triangles. A line segment is part of a line containing two endpoints and all of the points between them. A triangle is formed by three line segments that intersect at their endpoints. A point where the segments intersect is a vertex. The three angles that lie inside a triangle are called interior angles. If we're given a triangle, such as triangle XYZ, so let's draw a triangle here. If I have X, Y, and Z, we can write that as the triangle symbol with X, Y, and Z, and show that it has sides and angles using its vertices, which is just plural for vertex. So we have our corner here, our vertex of X, vertex of Y, vertex of Z. And we can name different things using those vertices. So angle Y can be written with symbols, such as the angle symbol with a Y. Or we could say angle XYZ, where the angle that we're naming is the one in the middle, or ZYX. Again, the one that we're trying to call is in the middle. The sides can be named using segment notation. So if I wanted to name this side right here, that would be side XY, because it's between X and Y, and it would be read as segment XY, and we would write it with a little line over top. So let's name the missing sides, vertices, and angles that are shown in the picture. So first, let's do the sides. In green here, they have the side between X and Y, so we call it segment of XY. Here we have Y and Z, so because it's the side, we're going to call it segment YZ. And then here we have between X and Z, I have segment XZ. In general, we're going to put them in alphabetical order. For the vertices, we can just name it the vertice of what corner it is. So the vertex here that's highlighted is X, so we just say it's X. The vertex of Y and our vertex of Z. For the angles, this is where we have a couple different options. So in that corner, we have angle X, but we could have also called it angle YXZ or ZXY. In the next one, we have angle Y, but we could have also called it XYZ or ZYX. And last, we have angle Z or XZY or YZX. As we're going through this, it is going to be important to understand what angle or what side or what vertice we are talking about in order to solve some of our problems. Let's learn angle sum of triangles. The measures of the angles in a triangle have a special relationship. Here's a way we can see what that relationship is. If we were to draw a triangle like the one shown below, and then tear off each corner, as they show, and then we rearrange those torn pieces so all of the corners met at one point, we can see that the angles form a straight line. So down here we have a straight line. This means that those angles are supplementary, so those angles add up to 180 degrees. So considering this triangle here, our equation, if we're trying to find the measure, or if we're using that measure, we know that 110 plus 45 plus 25, they have to add together to equal 180 degrees. And this is going to become helpful if we're solving for missing angles, because we know that the interior angles will add up to 180 degrees. So our key concept here for angle sums of triangles, in words, the sum of the measures of the interior angles is 180 degrees. In variables, we would say that the interior angles X, Y, and Z add up to make 180 degrees. And we can see with our model, the angles X, Y, and Z are the interior angles. Example 1. Find missing angle measures. Find the value of X in the flag of St. Kitts and Nevis. So down here we have a triangle in that red part. I can see they gave us an angle up here of 56. Down here it's a right angle as the corner, so I know that that is 90. I want to figure out my missing value for X. So I'm going to write out my equation to solve for X, and I know that my three angles add up to 180 degrees. So to solve for X, I'm going to add the two that I know together. which is 146. Then subtract that from 180. X must be 34 degrees. I could have also just subtracted 56 and subtracted 90. Either way, we should get 34 degrees. So the value of x in our triangle must be 34 degrees. And we could check our answer if we plug 34 back in. 34 plus 56 is 90. 90 plus 90 is 180. So yes, we have the correct answer. Check your understanding. What is the value of x in the doghouse shown? Pause the video now and complete the check. Check your answer. You should have said that x is equal to 47 degrees. We could find this by subtracting each of those angles from 180, or add them together first and then subtract from 180. So adding them together would give me 133. 180 minus 133 is 47. Let's learn exterior angles of triangles. In addition to its 3 interior angles, a triangle can have an exterior angle, and that's formed with one side of the triangle and the extension of the adjacent side. So if you see here in the picture, it's like we took the sides of the triangle and just kept them going, forming our interior angle that's actually in the triangle, and then another exterior angle. So in our diagram here, 4, 5, and 6 are exterior angles, and they are supplementary to the adjacent angle because the two make a straight line. So 1 and 4 here make that straight line, so that's 180 degrees. And that is going to be a very helpful fact. So 1 and 4, we can see down here, angles 1 plus 4 is equal to 180 degrees. They are supplementary. So angle 6 and angle 2 are going to be supplementary, add to 180. And then angles 3 and angle 5 are going to be supplementary. So the exterior and interior pairs will make 180 degrees. Each exterior angle of the triangle also has 2 remote interior angles that are not adjacent to it. So angle 4 is an exterior angle. Angle 1 is the angle pair that's interior. So the remote ones, remote meaning like far away, not being used, are angles 2 and 3. So which angles would be remote to angle 5? So if angle 5 is over here, which ones are far away? It would be angles 1 and 2. What about for angle 6 over here? Which ones are far away? 1 and 3. So the remote interior angles are the ones away from the exterior. And those also have a special relationship. So we can see here the relationship using the example shown. So interior, we have 60 plus 55 plus 65. We know those 3, because they're all interior, they add to 180. We also know down here, 65 and 115 also equal 180. What this is trying to show is that the 3 angles that are inside is equal to those 2 angles outside. And if we get rid of the angle that's inside, we can see that down here, we're trying to subtract it away, that the exterior angle and its 2 remote interior angles are equal. So exterior angle 115, 60 plus 55 is also 115. The sum of the remote interior angles is going to be equal to the exterior angle. Now, if you were trying to find a missing angle, and you could use this fact, or you could just use the properties of interior angles and supplementary to get there as well, but this could help you skip right to the answer if you need to. Our key concept here was about remote interior angles. So the measure of an exterior angle is equal to the sum of the measure of its 2 remote interior angles. So we can see in our model here and with our symbols that angle A and angle B added together give us our exterior angle 1. Example 3, find exterior angle measures. In the beach chair shown, the measure of angle 2 is 55 and the measure of angle 3 is 60. So I'm going to write those in there, 55 and angle 3 is 60. I want to know the measure of angle 1. So angle 1 is an exterior angle, while 2 and 3 are both remote interior angles. So I know now that remote interior angles added together tell me the exterior angle that's away from it. So 2 and 3 added together will give me 1. 2 is 55, 3 is 60, so adding them together, 115. So the measure of angle 1 must be 115 degrees. If I don't remember this property, I also could find the measure of the other interior angle. So if these two together are 115, then this must be 65. And if that's 65, then supplementary over would still give us 115. So there are other ways to find exterior angles using the fact that its interior pair is supplemented. Either way works. Check your understanding. Using the picture and information provided, find the measure of angle 1. Pause the video now and complete the check. Check your answer. You should have said measure of angle 1 is 70 degrees. Angle 2, 25. Angle 3 is 45. Those are remote interior angles. So if I add them together, I get my exterior angle over here. Adding them would be 70 degrees. Example 4. Use exterior angles to find missing angle measures. In the figure, the measure of angle 4 is 135 degrees. So let's write that down. Find the measures of angle 2 and angle 1. So angle 4 is an exterior angle. The two remote interior angles are 2 over here and LKM. So the middle letter tells us where angle it is. And because that's a right angle, I can see that symbol. I already know that that's 90. So I know that these two together equal that exterior. So measure of angle 2 and the measure of LKM is equal to that. LKM is 90. Measure of angle 4 is 135. Now to solve for angle 2, I would just subtract. Angle 2 must be 45 degrees. Now, to get angle 1, I have a couple different options. I know that the interior angles add to 180, or I can also see that angles 1 and 4 are supplementary, so they would add together to be 180. Either way, we can solve by subtracting, and we would get 45 degrees. So angles 1 and 2 both happen to be 45 degrees. Check your understanding. Using the figure and the information provided, find the measures of angle 1 and angle 2. Pause the video now and complete the check. Check your answer. You should have said angle 1 is 57, angle 2 is 33. To get that angle 5 down here at 147, I'm going to do this one as supplementary right away, so I would know that that's 33. Then I'm actually, instead of doing the exteriors equal to the remote interiors, I'm going to use my interior sum as 180. So this is already 90, which means if I take away 90 and 33, then I am left with 57 degrees for that one. Again, I also could have done my remote. 90 plus 57 is 147. Either way, I get the same answer. Let's apply what we've just learned to geometry. So what are the measures of angles CDE and BCE in the figure? So first, let's figure out what our task is and which angles we actually need to figure out. So I want CDE, which is here. I start at C, go to D, end at E. So I need to know this angle here. And then I also need to figure out BCE. So BCE is saying figure out this angle right here. So that's my task. I'm trying to figure out those two values. So how could we approach this task? What things can we do? Pause the video now. See if you can think of any strategies that we can use to start to accomplish figuring out those two angles. Hopefully you said something along the lines of using our exterior angle properties, our interior sums, and supplementary angles. Maybe you also said something about the fact here that we're given with parallel lines. Maybe there's something about alternate interior angles or alternate exterior angles. So now let's figure out our solution. This is going to be a little complicated to figure out, but let's start working our way through. I'm going to start with BCE here and kind of ignore the bottom half for now. So I'm going to use the fact that in this triangle here, I have a remote interior angle, a remote interior angle, and the exterior angle. So if I'm solving for this, I know that these two added together equals this exterior angle. So 42 plus 2x minus 21 is equal to 3x minus 21. Now I'm going to solve for x. So if I go through that, I'm going to start by adding 21, and I just see that it's on both sides, and if I do that, it actually just cancels. I could have done it here too, but then if I add 21, I'm right back to where I started. I'm also going to subtract 2x from both sides. I end up with 42 on the left, because now that's gone. 3x minus 2x is just 1x, so x must be equal to 42. Now, neither of these angles are x. X is inside the parentheses there. So to solve for what that angle is, I actually need to plug in what x is. And I could do it with this one, or I could do it with the one down here. But since I need to do it anyway, or I'm trying to figure out BCE, I might as well just do it to the one I'm trying to figure out. So 3 times 42 is 126, minus 21 is 105. So BCE is 105. I'm going to erase and start over, but I now know instead of this crazy thing that is 105. Now I'm going to use my remote interior angles and my exterior angle again. 3y plus 2y, my two remote interior, must be equal to our exterior angle at 105. So 3y plus 2y is 5y. Those equal 105. Divide both sides by 5, I get y is equal to 21. That's not our final answer yet. I have to plug it back in. And since I want this angle anyway, I'm going to just plug it in for here. So 3 times 21 is 63. So after all that, I found CDE was 63 and BDE was 105, all by using the properties of our exterior and interior angles. If I wanted to use interior sums of triangles, I could have found that this interior angle here was 75. Then if I add those three together, I would end up making those three equal to 180. Still solving for y, I would get 21. So multiple ways to do the same thing. And even another way, if I had found this angle up here from before, instead of BCE, I could have theoretically even used alternate interior angles. Here's our parallel lines, they're inside, opposite of the transversal. I could have used that and said that 2x minus 21 is equal to 3y and figured it out that way. So many, many ways to figure out the same values. How can we show our solution is reasonable? We can take our values that we got, use a different property. So for this one, since we use the exterior angles and remote interior, after I figure that this is 63, and then if I plug in y here, which was 21, I'd get 42. Do those three things add up to 180? Yes, they do. So I could plug it in and double check to see that a different property works. And if it does, then we can be pretty sure we're correct. Check your understanding. Use the diagram below to find the measures of FDE, DEF, and FHG. Pause the video now and complete the check. Check your answers. FDE, so FDE, that angle there is 44. DEF, that one right there is 66. And FHG is also 44. So here to get that, we would want to start by solving for these two over here first, solving for x, using our exterior. So 2x plus 3x must be equal to 110. So 5x is 110. Oops, 110. So x must be equal to, if I divide by 5, x is 22. So 2 times 22 is 44. 3 times 22 is 66. Then, if I just use my alternate interior angles, this one here is the same as this one here. There's my transversal. Alternate sides inside the parallel, they must be equal, so that is also 44 degrees. Again, it's important to remember when you solve for x, you need to plug it back in to calculate out your actual angle value. Unless it's just x, but these are not.